Dear students, welcome to the 6th DSP class. Today is your 4th class session. You are going to study about the next classification of the signal, that is energy and power signals. Okay. Before going to start the today's class, just I am revising what we studied in the last class. What you studied in the last class? We studied the continuation of the even and odd signals. In that you studied one derivation and did the one problem to find the even and odd signals. And next you studied about the periodic and the non-periodic signals. Okay. Today's class you are going to study about the energy and power signals. Energy and power signals. Okay. So today I am going to teach you only about this because I am giving you the assignment today. Please write that assignment in one notebook and send through the Teachment app only. Assignment questions also appears in the Teachment app. Tomorrow is the last date for the submission of the assignment. Okay, after that is not going to accept your assignment. So that is why what I am doing means only I am explaining only one concept in today's class, that is energy and power signals. Begin the class with the energy and power signals. Here for this also it has only one simple derivation. According to that derivation we are finding the what is the energy equation and the power equation. Okay, for that what we have to do means first we have to consider a one resistance. Okay, let us say R is the resistance, and if it is excited by the voltage then we are going to call it as V of T. Let us consider the resistance R excited by the voltage V of T, and when it is excited by the voltage then it is going to produce the current I of T. Okay, simple one circuit is there. For that circuit resistance is connected. You are applying voltage. When you are applying the voltage to that resistance, current is produced. Okay, R is the resistance, excited voltage is V of T, and producing a current is I of T. Here let us assume that R is equal to 1 ohm. Then we have, if R is equal to 1 ohm is nothing but what? All the current and voltage are same, and that we are taking as X of T. X of T is nothing but what? Our signal. Correct? I of T is equal to V of T. When R is equal to 1 ohm means we are getting voltage is equal to the resistance, and that is equal to X of T. Okay, next, the instantaneous power expanded in R is equal to 1 ohm is given by power is equal to what? Power is equal to I into V. Okay. In that I into V is nothing but what? X of T into X of T. X of T into X of T is X square T, and it is watts. Power is equal to X square T into watts. Let us take this is our first equation. Okay. So actually what is the A means we are taking the signal. This is one signal. Usually X of T is nothing but what? Your continuous signal. We are taking this continuous signal and we are finding the equation for the energy and power. How we are taking that? By all this. Okay, till now what I have explained. Now finally what I got, P of t is equal to x square t watts. This is your first equation. The power dissipated in 1 ohm resistor is called the normalized power. Another one point just you have to remember. Here what happens? Our resistance is equal to 1. When resistance is equal to 1, okay, if the power is dissipated for the resistance is equal to 1 ohm, then it is called a normalized power. Okay, next, the total energy E and the average power P of the signal x of t are given as. Okay, I will read it once again. So next step is we are going to find the total energy and the average power for what we are finding for this x of t signal. Okay, we have found the P of t by taking x of t. We found P of t. By using this, we are going to find the total energy and the average power of the signal x of t. They are the energy and power signals for the continuous time signal. Okay, now so let us find the total energy E and the average power P of the signal x of t. Using the x of t, we have to find the total energy. So E is equal to what happens? Minus infinity to plus infinity x square x of t into dt. So in this equation, total power you are finding. Sorry, total energy. So why they have taken the minus infinity to this? So this is whatever power equation. Okay, why we have to take the infinity sign? Sorry, this integration, because always what happens, the integration is nothing but summation. Okay, integration is nothing but the summation. So that is why we have to, whenever you are finding the summation, you should take the integration sign. Okay, so and minus infinity to plus infinity, total energy is nothing but what its value includes from minus infinity to plus infinity x square into t into dt. This is your equation number 2. Similarly, to find the average power, we have to take the limit that to t tends to infinity 1 by t, and this is summation minus t by 2 to plus t by 2 x square t dt. This is your equation number 3. Okay, and next, if x of t, what is x of t? Our power equation. Sorry, our signal power signal equation x of t. If signal is the complex, then equation 2 and 3 can be written as like this. If you find what is the difference between this and this, nothing is the difference. Only the thing is we have to take the modulus sign for this signal. Okay, for this x of t signal, we have to take the modulus signal. Nothing is the change in this equation and in this equation. Okay, first what you have to say? First you have to take the R. R is nothing but what? The resistance that is excited by the voltage B of t. When excited by the voltage means it is going to give you the current that is called I of t. Because of R is equal to 1, V of t is equal to I of t. That means current is equal to voltage. When the current is equal to voltage, then what happens? That we have taken as an x of t. That means it is a one signal. And that x of t is nothing but what? Our 1. signal. Next we are finding the power. Power is equal to x of t into x of t, that is equal to x square into t. Okay, and by using that we are going to find the total energy and average power of the signal. Total energy can be written as minus infinity to plus infinity x square t into t. So here total we are finding, so that is why you have to take the integration sign, that is for the summation. And let us take, this is our equation number 2, and power equation is equal to limit t tends to infinity 1 by t minus t by 2 to plus t by 2 x square t into dt. This is the third equation. And here what happens, x of t is a complex. Then this equation 2 and 3 can be written like this. Only the change in the difference is this modulus sign. When you are taking the modulus, then equation number 4 and equation number 5. Okay. So next, if x of t is periodic, then equation 5 becomes. Okay. So for your reference, I have taken here the equation number 5. So what we got, the equation number 5, that is p is equal to limit of t tends to infinity 1 by t minus t by 2 to plus t by t x of t square. Okay, this is what our equation number 5. Okay, this equation number 5 can be written as, if it is periodic, is nothing but what, it is one from 0 to t. Okay, so only that's the thing what we have to do means we have to change the limit, and what here you have to say 1 by t and 0 to t, and with the modulus sign we have to write x of t. Everything is the same. Okay, d of t. This is our equation number 6. So this is the equation for the continuous time signal. This is the power equation for the continuous time signal. Next what happens, the same equation we have to do for the discrete time signals. What we have to do, the same equation you are going to get, but only the change is you have to change t to n. When you are changing from t to n, the same equation becomes the equations for the discrete time signal. That is E is equal to n is equal to minus infinity to plus infinity x of n. When you are writing, then it is called the energy equation for the discrete time signal. Let us say this is equation number 7. And the power equation is also the same, only the thing is instead of t you have to take the n. Okay, then it becomes the power equation for the discrete time signal. So next, once again what happens, if x of n is the periodic, then its average power is given by 1 by n. N is equal to 0 to n minus 1 x of n square. This is your equation number 9. Okay, only this about your energy and the power signals. Okay, let us hope we have covered all the classification of the signals. All the classification of signals are completed. Okay, in the next class we are going to study some other part of the DSP. That is very interesting also. Okay, so here some points are there from the equation 4 to 9. Okay, please you go through this. These are self-understanding. So what happens here? X of t or x of n. X of t is nothing but what your continuous time signal. X of n is the what your discrete time t. Time is defined to be an energy signals. Okay, if and only if the total energy content of the signal is finite quantity. That is, energy is in lies between 0 to infinity. All energy signals will have zero average power. That is, power is equal to 0. Okay. So till now what we have studied from equation number 4 to 9. These are the conclusions. And next, x of t or x of n is defined to be a power signal. If energy, that means your energy lies between 0 to infinity, then what happens? Power is equal to 0. Then x of t and x of n are called the energy signals. When they are going to call the power signals, P lies in between 0 to infinity. When P lies between 0 to infinity, then x of t or x of n are called the power signals. And what about the E signal? That means energy signal, that is equal to infinity. Okay, these are the important points you have to remember. Power and energy signals are mutually exclusive. Okay. However, there could be a certain classes of signals which do not satisfy both the classification referred above. Such signals are neither energy nor the power signals. What is the meaning of this one? Power and energy signals are mutually exclusive. That means power and the energy signals can be changed. That means the same signal can be the power signal 1 when it is lies in between 0 and infinity, and when it is power is lies, then it is called the power signals. That means when P is equal to 0, if the value of this E lies between 0 to infinity, then they are called the energy signals. And when E is equal to infinity, P values lies in between 0 to infinity, then they are called the power signals. So that is why they are mutually exclusive. But sometimes we are having some class of the signals, they do not satisfy these conditions. That means it not be a 0, it not be the infinity, it may be value from minus infinity to plus infinity. Then we are going to say that that type of the signals are not the energy signals or not the power signals. Okay. Okay, these are the reference. And this is the my concern about my students. Stay home, stay safe, stay healthy. You are very precious to your family. Okay, this is the you are precious to our department, so that is why it is my precious sentence. Go through again and again for better understanding of this video. Okay, please find the assignment in the teach me tab. Okay, meet in the next video.